Hello everyone, and welcome back to the Fluctus Channel. On the ground, one of the oldest ways to stop an army is still one of the most dangerous obstacles. Wire, mines, trenches, craters, and hidden explosives can slow a unit long enough for defenders to strike. Combat engineers and explosive ordnance disposal teams are trained to open paths through these barriers. But the work is dangerous because the person clearing the obstacle is often close to the blast, exposed to fire, and forced to work under pressure. During EOD missions, teams approach suspicious objects with discipline, mark the area, study the device, control movement around it, and decide whether to remove, disrupt, or destroy it in place. These barriers may look silent, but they can control an entire battlefield. Manually breaching anti-personnel obstacles can be even more risky. A wire obstacle may look simple, but it can be tied to mines, tripwires, booby traps, or enemy observation. Engineers carrying demolition charges must crawl forward, prepare explosives, place charges, run firing lines, and move back before detonation. During bilateral demolition training, Marines and partner forces rehearse these tasks again and again because hesitation at the obstacle can stop the entire assault. That is why new flying robots are changing the problem. Anduril's Ghost X gives soldiers an autonomous, small, unmanned aircraft that can scout ahead, carry mission payloads, and operate from rough field locations. It has been advertised with up to 90 minutes of endurance, about 25 kilometers of range, and a payload capacity of up to 25 pounds. For Army units integrating artificial intelligence and small drones, the advantage is not only flight, it is the ability to keep humans farther from the first point of danger. The setup begins with batteries, payload checks, communications links, mission planning, and a launch area. Operators unfold or prepare the aircraft, confirm the controller, check sensors, verify route data, and make sure the drone is responding before sending it into the air. At night, the challenge grows. Drone operators train with limited visibility, using screens, thermal imagery, navigation cues, and radio discipline to keep the aircraft oriented. A small mistake in darkness can mean losing the drone, missing the target, or placing a payload in the wrong location. The most striking process comes when engineers use a drone-delivered Bangalore torpedo to breach a wire obstacle. Traditionally, a Bangalore torpedo is a long, explosive charge pushed under barbed wire to blast a lane. With a drone, engineers can load the charge, secure it under the aircraft, check balance, and fly it toward the obstacle. The operator approaches carefully, lowers the payload, releases it near or across the wire, and backs away. Once the team confirms the charge is positioned, they initiate detonation from a safer distance. The blast tears open the obstacle, creating a narrow lane where troops or vehicles can continue forward safely. The flying robot does not remove danger from war, but it changes exactly who has to stand closest to it. Drones can attack a single obstacle from above, But armies still need heavy vehicles that can smash through minefields, wire, and earthworks while under fire. That is the purpose of armored breaching vehicles. An ABV is built around one basic idea: protect combat engineers while they create a path for the rest of the force. Instead of sending soldiers forward on foot, a heavily armored vehicle drives toward the obstacle carrying plows, rollers, explosive line charges, markers, smoke systems, or demolition equipment. Its armor gives the crew time to work in areas where rifles, fragments, and mines would make foot movement almost impossible. Germany's Keiler mine-clearing vehicle is one example of this approach. Based on a tank chassis, the Keiler uses a rotating flail system to detonate or destroy mines in front of the vehicle. As it advances, heavy chains spin against the ground, striking the soil and triggering buried explosives before following troops reach them. The process is violent and slow, but that is the point. A minefield is not crossed by speed alone. It is crossed by method, armor, and controlled destruction. The crew inside must keep the vehicle aligned, maintain the clearing lane, watch for mechanical stress, and coordinate with units waiting behind. Dust, detonations, and uneven ground make the lane difficult to read, so discipline matters. German mine-clearing ladder systems show another method. Instead of striking every mine with a flail, a vehicle can push or launch a structure across a dangerous gap, obstacle, or mined surface, giving following forces a defined crossing path. The operation requires careful positioning. The vehicle approaches, halts at the correct distance, lowers or deploys the equipment, confirms that it is seated, and then allows troops or lighter vehicles to move through the breach. Every step depends on timing, because a breaching vehicle that stops too long can become an obvious target. Modern industry is combining these ideas into next-generation breaching systems. Rheinmetall's concepts bring together armor, mobility, sensors, lane-marking tools, mine-clearing attachments, and remote or protected crew operation. The best features are the ones that reduce exposure: strong armor for the crew, mechanical tools for the minefield, sensors for awareness, and systems that mark a safe lane behind the vehicle. The first safe lane often decides whether an attack keeps momentum. The United States uses similar thinking with the assault breacher vehicle. Based on the M1 Abrams chassis, it carries a full-width mine plow and can fire line charges to blast lanes through mines and wire. During combat engineer training, crews prepare breaching charges, inspect explosive systems, move into position, and coordinate with infantry or armor waiting to pass. The sequence must be exact. Mark the obstacle, suppress the enemy, obscure the area with smoke if needed, reduce the obstacle with charges or plows, then assault through the lane before the enemy can recover. Whether it is a German Kehler, a future Rheinmetall breacher, or an American ABV, the mission is the same: turn a deadly barrier into a passage. The other side of breaching is mine laying. If breachers open a route, mine layer vehicles are designed to close one. A German mine layer vehicle can place mines across roads, fields, or avenues of approach, creating an obstacle that slows enemy movement and forces engineers to expose themselves during clearance. The purpose is not random scattering. A useful minefield is planned around terrain, observation, fire support, and movement. The process begins with loading mine canisters or dispensers into the vehicle. Crews check the system, confirm the route, and coordinate with commanders so the field is recorded and marked. As the vehicle moves, the dispenser places mines at set intervals behind or beside it. Spacing matters because the minefield must be dense enough to slow an enemy but organized enough to be documented for clearance. Mine lane vehicles cover ground much faster than soldiers working by hand. They allow a defensive force to shape the battlefield in minutes. Once the mines are laid, the location must be reported and mapped. Without records, the obstacle can become a danger to troops and civilians later. That is why mine lane and mine clearance are linked. One creates the barrier. The other must remove or breach it. Obstacles are not limited to land. At sea, a mine can threaten a destroyer, submarine, carrier, patrol craft, supply ship, or harbor entrance without ever being seen from the bridge. Naval mines are dangerous because they are patient weapons. They can sit below the surface, drift near shipping lanes, or float close to a ship until contact, pressure, magnetic influence, or acoustic signals make them deadly. That is why U.S. Navy explosive ordnance disposal teams train to deal with ordnance above, below, and beside the water. Navy EOD has a history built around hazardous work. Its sailors handle bombs, missiles, improvised devices, underwater mines, and unexploded ordnance in places where a mistake can be fatal. During the Gulf War, mine warfare was a constant danger, and EOD teams played a major role in keeping sea lanes, ports, and naval forces moving. It marks a community that exists because modern warfare leaves dangerous explosives behind. Underwater ordnance disposal begins with finding the threat. Divers, sonar teams, unmanned systems, and mine countermeasure units search the seabed or water column for suspicious shapes. Once a mine is located, the team studies its position, depth, condition, and possible firing mechanism. Divers may approach slowly through limited visibility, using lines, hand signals, underwater tools, and strict procedures. They do not rush. They identify, mark, and decide whether the object can be moved or must be destroyed where it rests. For floating mines, the response is different. A mine drifting near a ship or coastline must be tracked, isolated, and destroyed before it reaches a populated area or naval traffic. During a floating mine response, crews keep safe distance, warn nearby vessels, and prepare a demolition charge or controlled firing method. The goal is to neutralize the mine without pulling ships or people into the danger zone. Locating and exploding underwater mines requires patience. A demolition charge may be placed near the mine, connected to a firing system, and detonated from a safe distance. The shock wave destroys or disables the explosive device, sending water and debris upward. Mine countermeasures can also come from the air. Navy minesweeping helicopters tow equipment that creates magnetic or acoustic signatures to trigger or detect mines from a safer distance. Airborne minesweeping keeps sailors farther from the danger while covering large water areas faster than divers alone. From drone-delivered Bangalore charges on land to armored breachers, mine layers, and Navy EOD teams at sea, the struggle is always the same. Obstacles are built to stop movement. Engineers, robots, vehicles, divers, and aircraft exist to reopen the route. The future battlefield will not remove mines or barriers, but it will keep finding new ways to defeat them while protecting the people who must move forward. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.